Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is inverse of an exponential function. So far we have seen many functions like absolute value function, constant function and many. In this video we are going to particularly concentrate on the exponential functions. In this video I have 3 examples to show you and I'll explain you how to determine algebraically the inverse of an exponential function. But before we take a look at the worked examples, I suggest that you review the suggested steps in order to have a good grasp of the general procedure. Now let me list out these steps to find the inverse of an exponential function. Step 1 is as usual, as how we do all the other functions. Change f of x to y. Step 2 is to interchange x and y in the given equation or function. Generally we use to swap the roles of x and y. Next step, step 3 is to isolate the exponential expression on one side of the equation. You can either isolate it on the right side or left side of the equation. But what we have to do is isolating the exponential expression and shifting all the other expression terms to the other side of the equation. First, let me give you the exponential expression, a general form of the expression. The exponential expression shown on the board is a generic form where b is the base and n is the exponent. Next step, step 4 is to eliminate the base b of the exponential expression by taking the logarithm on both the sides of the equation. Generally, what we do to remove or get rid of any term, we just do the opposite operation. Am I right? Same way, the opposite operation to get rid of the exponential e is to take the logarithm on both the sides of the equation. That is what we are going to do in this step. To make the simplification much easier, take the logarithm on both the sides. Use the base of the exponential expression itself. As I have already mentioned many times in all my videos, whatever you do to one side of the equation, you have to do the same thing on both the sides of the equation. Otherwise, our equation will be unbalanced and we may end up with the wrong answer. So whenever you are doing something on one side of the equation, to make the equation balanced, you have to do it on both the sides of the equation. And let me show you how to use the log rule. Log of the exponential function b raised to n is nothing but n. This is actually a logarithmic rule we will be using wherever we need to get rid of the exponential function, or in case if a variable is in the exponent's place, you can bring it down by taking the log on both the sides. Let me write this elaborately. Hope you're clear so far. And the next step is to solve the exponential equation for y to get the inverse. And finally, we will replace y with the inverse notation f inverse of x as we do in all the other functions to write the final answer. These are the suggested steps to solve some problems on exponential function. Please have a glance over this. Now I am going to take few examples and explain you how to apply these steps one by one and get the inverse of the function. Here is your first example. Here is the first example. Please look at the function given. We have x in the exponent's place. The base is 2 and the exponent is 3x minus 5. This should be an easy problem because the exponential expression is on the right side of the equation, is already isolated for us. Okay, so let us start by replacing the function notation f of x by y. Next step is to switch the variables x and y in the equation. Since the exponential expression is by itself on one side of the equation, we can now take the logarithm of both sides. When we get the logarithms of both sides, we will use the base of 2 because this is 2, because this is the base of the given exponential expression. So you have to take the base depending upon the given exponential expression. Let me write the logarithmic rule for your recap. We are going to apply the log of exponent rule in the simplification. This rule states that a logarithm of an exponential number where its base is the same as the base of the log is equal to the exponent. So let us apply the same concept here. Take log on both the sides of the equation. The left side of the equation will be as it is, log base 2x, and on the right side log base 2 and 2 gets cancelled out according to this log of exponent rule. So only the exponent will be left over on the right side. That is the reason we are applying this log of exponent rule. We are almost done. Solve for y by adding both the sides by 5 and then divide the equation by the coefficient of y, which is nothing but 3. Adding 5 on both the sides of the equation, I get this gets cancelled out. Dividing the equation throughout by 3, I get, you can either write the left side of the equation with two different fractions or a fraction with common denominator. Both are same. And on the right side we have y isolated. Please don't forget to change y to f inverse of x to mean that we have the inverse function. If we graph the original exponential function and its inverse on the same xy plane, they must be symmetrical along the line y equal to x, which they are. Let me show you the graph too. This is our original function, the blue graph, and f inverse of x is log base 2x plus 5 over 3, and I have drawn this graph in red. I have also drawn the line y equal to x. Just to make a difference, I have used dotted line. And after drawing this line, you can notice the symmetric. That's it for this example. Hope you're clear with this example. Okay, let me show you one more example. Here is the next example. Please look at the question. By observing the question, you can say that the only difference between this problem from the previous one is that the exponential expression has a denominator 2. Am I right? Other than that, the steps will be the same. Okay, I'll show you the steps. We change the function notation f of x by y. So I'll get 5 4x plus 1 over 2. Swap the x and y's. So we have switched x and y. At this point, we can't perform the step of taking the logarithms on both the sides just yet. The reason is that the exponential expression on the right side is not fully by itself. Am I right? We have to get rid of the denominator 2. So what can we do that? Either we can multiply both the sides by 2 or just cross multiplication. Both are same. So by cross multiplication or multiplying both the sides of the equation by 2, we will get 2x on left side and 5 raised to 4y plus 1 on the right side. We have isolated the exponential expression on one side of the equation. It is now possible to get the log on both the sides. So when you do this, always make sure to use the base of the exponential expression as the base of the logarithmic operations, because in this case the base of the exponential expression is 5. Therefore we apply log operations on both the sides using the base of 5. Okay, let me write the rule and then show you how I am applying that. Until you get complete practice, you have to mention the formulas and the rules or the laws wherever that you're applying. Okay, using this log rule, the 5's will get cancelled out, leaving the exponent 4y plus 1. Am I right? So this is great. Since the log portion of the equation is gone, we can now finish this up by solving the variable y, then replacing it by f inverse of x to denote that we have obtained the inverse function. So taking log base 5 on both the sides, we get left side would be the same, and on the right side we are going to apply this law. So log base 5 and base 5 will get cancelled out and will be left over with 4y plus 1 on the right side. We need to isolate y, so I'm going to subtract 1 from both these sides. So I'll get 4y. Now I need to get rid of the coefficient of y, that is 4. So I'm going to divide the entire equation by 4. So I'll get log base 5 2x minus 1 divided by 4 equal to y. Replace y by log inverse of x, because we have to denote that we got the answer inverse finally. Can you follow so far? That's it for this problem. We have got the inverse of the given original function. For all these problems, you have to graph the given function and its inverse as and check whether they are symmetrical about the line y equal to x, so that you can check and confirm that your answer is correct. Okay, let me draw the graph on the board. Here is the graph of the original function and the inverse, and I have also drawn the y equal to x line. You can check the symmetry. Does this make sense to you? Okay, I'll take a bit difficult level example and show you. Here is the next example. I see that we have an exponential expression being divided by other. Am I right? So the good thing is that the exponential expressions have the same base 3 and 3. So we should be able to simplify this using the division rule of exponent. When the bases are same, our job will be a bit easier. So let us use the division rule of exponent. Here is the rule. To divide the exponential expressions having equal bases, I mean the same bases, copy the common base and then subtract the exponents. I'll just write the rule of exponent. So when the bases are same in the fraction form, you just have to subtract the exponents keeping the base as common. This is the rule. Observe how the original problem has been greatly simplified after applying the division rule of exponent. Keep the base same, keep the first exponent as it is and write a minus sign in between and write the exponent in the second exponent. If you open this parenthesis or if you distribute this negative sign here, the signs in the second parenthesis will change. So negative 6x plus 5 plus 8x minus 6. If you combine the like terms, you will get 2x minus 1. Distributed the negative sign. Now combine the like terms. 8 minus 6 is 2x. 5 minus 6 is negative 1. Did you notice that we have simplified our expression? And this looks like a first example. Am I right? Now our simplification will be easier. At this point we can proceed as usual in solving for the inverse. I'm just going to rewrite f of x as y. And I'll just interchange the variables x and y. Switch x and y's. Before we can get the logs of both the sides, isolate the exponential portion of the equation by adding 4 on both the sides. Take logarithm on both the sides. Since the base is 3, I'm going to take logarithm with base 3. So if we apply the logarithm of exponent on the right side, this will get cancelled out and the exponent will be brought down. Add 1 on both the sides, we'll get divide both the sides of the equation by 2 so that y will be isolated on the right side of the equation. Now replace y by f inverse of x. It verifies that our answer is correct because the graph of the given exponential functions and its inverse, the logarithmic function, are symmetrical along the line y equal to x. Let me show the graph on the board. So always after finding the inverse, verify your answer by drawing the graph of the original function and the inverse that you got and check by the vertical line y equal to x. If the symmetry works, then your answer is correct. Hope you are clear with this topic. In case if you have any query, kindly let me know. Thanks for watching.